Imagine you are standing on this incredibly muddy, totally chaotic construction site of a massive liquefied natural gas plant.
Oh yeah, just a symphony of industrial noise and cranes everywhere.
Exactly. Cranes swinging overhead, thousands of workers rushing around, and up on a scaffold, a worker is installing a steel bracket and, it just accidentally scrapes a tiny patch of paint off a 4-inch carbon steel pipe.
Happens every single day.
Right. It is a completely routine, microscopic mistake. But on a multi-billion-dollar mega project, who pays for that touch-up paint? Like, who pays for the scaffolding to stay up an extra day while the new paint dries?
And if the people running the project do not know the absolute ironclad answer to that specific question before the very first shovel hits the dirt, well, that project is already on a one-way path to financial ruin.
Which brings us to the really fascinating material we are diving into today. Welcome to a brand new deep dive. Today, we are exploring the hidden, highly structured world of international construction contracts.
Specifically, we are pulling from the FIDIC Red Book construction contract schedules and preambles.
Yeah, and for anyone who hasn't encountered it before, the FIDIC Red Book is basically the global gold standard. It's the ultimate rule book for how to build massive infrastructure without everyone just suing each other into oblivion.
Although to the untrained eye, the sources we have today are just endless, dry spreadsheets.
Oh, totally. Pages and pages of unit rates, classification codes, just really dense contractual terminology.
On the surface, it reads like a phone book written by a very anxious accountant.
That is the best way to describe it. But our mission today is to decode these documents by zooming in on one hyper-specific, utterly fascinating focus area, which is cold insulation.
Right.
We are going to uncover how these contracts quantify, measure, and, actually price the incredibly complex engineering required to keep industrial systems freezing cold.
Because understanding the exactitude applied to just the insulation, it really reveals the incredible invisible math that prevents those billion-dollar disputes we were talking about.
It really does. And insulation often feels like an afterthought to people outside the industry, right? You see a pipeline and you naturally just think about the pipe itself or maybe the volatile gas flowing inside it.
Yeah, but the insulation is the quiet, invisible system that actually dictates whether the whole plant functions at all. I mean, if the gas gets too warm, it expands, pressure spikes, and the plant just shuts down.
Boom. Done.
Exactly. And in a FIDIC contract, the rules governing that quiet system are just staggering in their psychological and commercial detail.
So to even begin to grasp how they manage that on a muddy construction site, we really have to look at the vast menu of options the contract provides. And this is before anyone is even allowed to buy a single roll of foam.
Right. Which means we are entering the work breakdown structure, or the WBS matrix.
The WBS.
Yeah, the WBS is essentially the contractual DNA of the project. It categorizes every conceivable task, material, and labor hour into this really rigid hierarchy.
And in our sources today, we dive straight into WBS Level 4. Specifically, there's a code labeled HI0.
HI0.
Right. And that is the master classification for all things related to cold insulation. If a contractor is keeping things cold, it lives under HI0.
And then you drop down a level to the Level 5 codes, and you find things like Code 500, which is designated for Supply and Insulate Pipes Carbon Steel.
Which is a title that sounds deceptively simple, honestly.
Deceptive is exactly the perfect word.
Because you open the unit rate schedule for Code 500, and it's just a massive grid. The columns account for pipe diameter starting as small as like 1/4 of an inch, and they scale up in exact fractional increments.
3/8, half-inch, 3/4.
Yeah, all the way up to massive, cavernous 44-inch diameter pipes.
And remember, that only covers the steel pipe itself. The matrix then has to account for the actual insulation going around that steel.
Right, so every single one of those pipe sizes intersects with another set of rows dictating the required thickness of the insulation. It starts at 25 millimeters or less.
Then there is an entirely separate line item for 30 millimeter thick insulation.
Then 40 millimeters, 50, 60, stepping up in exact increments all the way to heavy-duty 200 or 300 millimeter thick insulation.
Which means you end up with thousands of unique permutations just for carbon steel pipe insulation.
Thousands. And for each of those tiny boxes in the grid, the contractor has to provide what's called a composite rate, which is measured in euros.
A rate that is firm and fixed for the entire duration of the contract. It's broken down into material cost, labor cost, and the exact man-hours required to install that specific unit.
I look at this grid and it literally reads like the world's most exhausting restaurant menu, where instead of food, you are ordering thousands of specific combinations of foam and steel.
It really is.
But I have to ask about the underlying logic here. Why go to the immense trouble of explicitly listing every single millimeter combination in a massive grid? Like, if you are insulating a cylindrical pipe, why not just use a standard mathematical formula? You and I both know the formula for the volume of a cylinder. Why wouldn't the contractors dictate a flat rate per cubic meter of insulation foam applied, completely regardless of the pipe size?
In a purely theoretical world, a formula based on volume is absolutely the most elegant solution. But a construction site is defined by physical friction.
Okay, what do you mean by physical friction?
A formula requires inputs, right?
Mm.
And inputs require subjective measurement by human beings. If you rely on a volume formula, you're practically guaranteeing that every single day you will have a contractor's engineer and an owner's engineer standing out in the rain arguing.
Just arguing over math.
Over the exact thickness applied at a specific coordinate. Or they'll be fighting over how a slight manufacturing defect in the steel pipe affects the baseline volume calculation.
Oh, wow. So the subjective measurement just becomes a weapon to inflate the bill.
Precisely. A 10-millimeter difference in thickness across, say, 50 miles of pipeline is a massive financial swing.
I didn't even think about the scale of it.
Yeah, so the WBS matrix exists to turn a complex, subjective physical volume into a simple, binary commercial choice. You look at the drawing. Is it a 4-inch pipe? Yes. Did the design specify 50-millimeter insulation? Yes.
Then the price is exactly this predetermined number of euros.
Exactly. There is no tape measure debate, no geometry formulas, and absolutely no subjectivity. It forces total cost certainty before anyone steps foot on site.
That transition from physical reality to commercial certainty is fascinating. It totally explains why a flat rate formula fails in the real world.
Yep.
But even with a menu of fixed prices, a grid is totally useless if the two parties don't agree on exactly how to count the items on that menu.
You still have to agree on how to hold the tape measure.
Right. If a contractor is billing for 100 meters of insulation, they need an ironclad rule for that. Which brings us to the true magic of the sources today, which is Section 3.4 of the Preambles, known as the Rules of Measurement.
These preambles are where the contract essentially decides to invent its own laws of physics.
That's such a great way to put it. Because the foundational rule stated here is that cold insulation is measured net as executed.
Meaning you only get paid for what is actually installed.
Yes, but immediately there is a massive exception. The preamble states that you do not deduct for small voids.
Right, the void rule.
Yeah. If there is a physical gap or an empty void in the insulation that is less than 1.0 square meter in area or less than 0.05 cubic meters in volume, the contract dictates that the void is completely ignored.
And you have to think about the administrative burden that single rule eliminates.
Because otherwise they'd be measuring every tiny gap.
Exactly. Without that rule, you would have inspectors demanding financial deductions because they found a 2-inch gap behind a structural support bracket.
But mathematically, the employer is willingly paying for insulation that does not physically exist in that small void.
They are. They are quite literally buying administrative peace.
It is a deliberate blindness just to save time. But the rules get even more counterintuitive when we look at how they measure the pipes themselves.
Oh, the centerline rule.
Yes. Section 3.4 mandates that insulation applied to pipework is measured in linear meters along the center line of the pipe.
Which is just an imaginary line running right down the absolute middle of the tube.
And the preamble is incredibly explicit about this. This imaginary centerline measurement goes straight through all inline fittings.
Yep.
Whether it is a bend, a 90-degree elbow, a T, a reducer, or a flange joint, you just run that imaginary tape measure right through the middle of the fitting and measure that total length.
But notice what it excludes. It completely excludes items of inline equipment, like valves and flow meters.
Right, and we'll get to the valves in a second, but hold on, I need to pause on this centerline logic. Because from a purely physical standpoint, this seems kind of absurd.
How so?
Think about a pipe curving in a sharp 90-degree elbow. The outer edge of that curve, like the long way around, requires significantly more insulation material, more cutting, and more labor than the really tight inside edge of the curve.
Oh, sure.
So measuring straight down the imaginary center line is technically totally inaccurate. The contractor is under-measuring the vast amount of material needed for the outside and over-measuring the inside.
Well, from a strict geometric standpoint, you are entirely correct. The measurement is a complete fiction.
Then why do they do it?
Because the contract isn't striving for geometric perfection. It is striving for commercial harmony. These measurement preambles create an artificial, Mutually agreed upon reality.
To avoid fighting.
Exactly. Imagine the alternative. If a contractor had to mathematically calculate the outside radius and the inside radius of every single elbow and bend on a petrochemical plant featuring 50 miles of complex, winding piping way.
Oh my God, they would need an army of surveyors working for a decade.
The cost of measuring the insulation would dwarf the cost of the actual foam.
Oh, okay, that is exactly the point. That's crazy.
So both the employer and the contractor just agree to live in this artificial reality. The agreement is simple, we will just use the center line.
Right, and sometimes you win, sometimes you lose.
Exactly. Yeah, sometimes the contractor will use a bit more material on an outer curve. Sometimes they save a bit on an inner curve. But across 10,000 elbows, it just averages out. And most importantly, it eliminates endless microscopic bickering over geometry.
The engineering of human agreement.
Yeah.
That makes total sense. Now, returning to the exceptions. The rules noted that the centerline measurement goes straight through joints and flanges, but it stops dead when it hits a valve.
Right.
Because a valve can't just be permanently foamed over, right? A maintenance crew is eventually going to need to turn it or service it. So how does the contract handle the measurement of something that needs to be accessed like that?
The preambles introduce a completely different categorization for those items. Flanged joints and flanged valves require what the contract calls removable blankets.
Which are what exactly?
These are custom fabricated, heavily insulated jackets that can be unbuckled and taken off by a maintenance worker.
Oh, okay. And crucially, looking at the sources, these removable blankets are not measured in linear meters. The measurement rules dictate they are enumerated. You just count them.
1 blanket, 2 blankets, 3 blankets.
Exactly. And they're measured as an extra overcost to the standard pipework. So the contractor gets paid the linear meter rate for the main pipe run, and then an entirely separate extra fee for fabricating and installing the custom removable blanket on the valve.
It creates a highly choreographed system of measurement.
Yeah.
And, it shifts again when you move away from pipes entirely.
Right, like big tanks.
Yeah. When the contractor is insulating equipment, large vessels or giant exhaust ductwork, the linear meter is abandoned completely. The rules dictate those are measured in square meters based on the outer surface area of the finished insulation.
So depending on the physical shape of the object, the billing department is constantly code switching between linear meters, square meters, and just like counting physical objects on their fingers.
It is a massive undertaking just to establish the distance or the area.
But that brings up the other half of the equation. Once everyone finally agrees on how to measure a single meter of insulation, we need to understand what that single meter's price actually buys.
Which leads us out of the rules of measurement and straight into the rate preambles.
Right. And in a standard FIDIC Red Book, the phrase supply and insulate carries a massive amount of hidden weight.
It really does.
It means far, far more than a worker just slapping some foam on a pipe and wrapping it in tape.
The unit rate a contractor bids is aggressively all-inclusive. The contract essentially forces the contractor to bundle an enormous amount of logistical risk into that single euro value.
The sources show that the composite rate must include all overhead, all profit, and what the industry calls preliminaries.
And the implications of that are wild.
Yeah, it means the contractor cannot issue a separate charge for scaffolding, right?
Nope. They cannot charge extra for bringing in specialized small tools. They cannot bill for the time it takes to haul materials across a muddy site, or the labor required to take delivery from a truck and unpack the boxes.
So the employer is transferring almost all the site-specific logistical risk onto the contractor.
Exactly. If a contractor bids a rate for insulating a pipe, assuming it is at waist height, but the actual pipe ends up being suspended 100 feet in the air and requires 3 days of custom scaffolding.
They just have to eat that cost.
The contractor simply eats that cost.
Bidding a composite rate on this contract is exactly like buying an all-inclusive resort vacation.
Okay, I like this analogy.
When you pay that lump sum up front, you aren't just paying for the bed in the hotel room. You are paying for the beach towel, the guy whose only job is to sweep sand off the walkway, the massive liability insurance premium the resort pays, the electricity running the pool pump.
And a little paper umbrella in your drink.
Yes, the little paper umbrella. The resort has mathematically baked all of those invisible costs into your nightly rate.
It is a great analogy. But the hidden labor requirements bundled into these cold insulation preambles go way beyond just providing scaffolding or sweeping up sand.
Yeah, it gets really technical.
The specific, highly technical tasks forced into that single composite rate are incredibly demanding.
Because the rate preambles literally list out the hidden labor. The baseline rate must include forming complex laps, cutting out the foam around unexpected structural obstructions, working around tiny, annoying drains.
And perhaps most importantly, ceiling pin penetrations.
Okay, tell me about the pin penetrations, because that seems huge.
That requirement is absolutely vital for cold insulation. Unlike insulating a hot pipe to keep heat in, cold insulation requires an absolutely flawless vapor barrier.
Because of the condensation.
Exactly. The environment outside the pipe is warmer than the freezing gas inside. If there's even a pinprick in the outer jacket, warm, humid air gets sucked in. That moisture hits the freezing pipe, turns to ice, expands, and systematically destroys the insulation from the inside out.
Oh, wow. It just blows it apart.
Yeah, so the contract rate forces the contractor to guarantee, completely on their own dime, that every single microscopic pinprick is sealed.
The level of detail is just staggering. And it expands beyond just the installation itself. The preamble dictates that the contractor's rate must cover the cost of protecting other people's work.
Right.
It explicitly mentions protecting painted surfaces and employer-supplied materials, which brings us right back to the scenario we started with. If the insulation contractor accidentally scrapes the paint off a pipe while installing a bracket, the dispute is already settled.
The insulation contractor pays to fix the paint, and they can't complain about it, because legally, the cost of that potential accident was already built into the composite rate they agreed to months ago.
They are essentially buying an insurance policy against their own workforce's clumsiness and wrapping that premium into the price of the insulation.
The foresight is really incredible.
It is. But my absolute favorite hyper-specific task buried in the rate preambles is the requirement for inspection plugs.
Oh, the contractual right to verify what has been hidden.
Yes. The rate explicitly mandates that the contractor must include the cost of cutting through the outer metal jacketing they just installed, then removing the complex insulation compound, allowing the employer's inspector to examine the bare steel pipe, putting the insulation back, and installing a permanent plug so inspectors can easily check that same spot years later.
And all of that incredibly tedious labor cut, remove, replace plug is just baked invisibly into the base rate for a linear meter of pipe.
When you lay out all these requirements, the scaffolding, the vapor barrier perfection, the accidental damage, the inspection plugs, you really have to wonder how a contractor possibly calculates a single fixed rate.
It seems impossible.
Like, how do you price a standard meter of pipe when you have to factor in totally unpredictable variables? You don't know if another trade will have left a massive obstruction in your way, or if a specific weld will require 3 rounds of inspections.
They survive by relying on mountains of historical data, massive waste factors, and really deep contingency modeling.
It's all statistics.
Yet when they submit that euro rate in the WBS matrix, they aren't pricing the specific reality of a single meter. They're pricing the statistical average of 1,000,000 meters.
Right. They know some meters will be an absolute breeze and some will be an absolute nightmare.
And the single composite rate has to be robust enough to absorb the nightmare without bankrupting the company.
It is a phenomenal exercise in risk management. But everything we have discussed so far assumes the environment is somewhat standard. And on an industrial site, not everything is just a pipe carrying a fluid.
Definitely not.
We've established the measurement and pricing for standard delivery systems, but these cold insulation preambles also have to account for extreme, highly specialized environments. Environments where the stakes escalate from mere financial risk to literal life and death.
Which takes us into the most critical structures on the entire site. Let's look at the Level 5 WBS codes dedicated entirely to liquefied natural gas, or LNG, storage tanks.
Found under WBS codes 510 to 514. These tanks are the beating heart of the facility. They are massive, sometimes the size of an entire city block. And keeping the millions of gallons of liquid inside them freezing cold is the entire point of the project's existence.
And the WBS schedule breaks an LNG tank down into highly distinct geographical zones. Code 510 dictates the bottom insulation. Code 511 is for the deck insulation.
Then there are completely separate codes for the inside of the outer wall and the outside of the outer wall.
And for all of these tank codes, we abandon the linear meter entirely and switch back to measuring by massive square meters of surface area.
Because the geometry of a tank the size of a cathedral is far easier to measure by surface area than attempting to trace individual piping runs, the scale just demands a different metric.
Exactly.
The scale is one thing, but as you scan down the WBS codes, the contract takes a really fascinating philosophical turn. If you look at WBS code 518, It falls under a completely different category.
It does.
It isn't labeled for a tank or a pipe. It is labeled personnel protection. It outlines the mandatory use of rigid PR pure insulation with 316L metal cladding.
With PIR and PUR standing for polyisocyanurate and polyurethane.
Right.
These are highly engineered materials with a closed cell structure. Think of millions of microscopic bubbles trapping gas inside the foam, which creates an almost impenetrable barrier to thermal transfer. It is highly efficient.
But the purpose of applying this highly efficient metal-clad foam under Code 518 is entirely unique. The preamble notes it is specifically to prevent cold burn.
Which is a phrase that sounds like a total oxymoron to anyone outside of extreme industrial engineering.
It really sounds impossible. But on an LNG plant, we are dealing with liquids that are hundreds of degrees below zero. Think about the classic childhood mistake of touching a wet tongue to a freezing metal flagpole in winter.
The moisture instantly freezes to the metal, and you are stuck.
Now multiply that by 1,000. If a worker leans against an uninsulated pipe carrying liquid natural gas, the ambient moisture in their skin instantly freezes to the raw steel.
Tearing away causes catastrophic tissue damage.
The freezing steel burns the human body just as violently and destructively as a red-hot iron pipe would.
And the inclusion of Code 518 represents a profound shift in the intention of the contract. Up until this exact line item in the schedule, every single millimeter of cold insulation we have discussed was designed to protect the process.
To keep the gas cold.
You insulate the pipe to keep the gas cold so it remains liquefied and the plant makes money. The process is the priority.
But with personnel protection, the process is completely irrelevant. The insulation is installed entirely to protect the fragile human from the extreme violence of the process.
It's a really stark contractual acknowledgement of the sheer physical danger of the environment these people are working in.
The rules of measurement are the same, the composite rates are calculated the same way, the WBS codes look identical on the spreadsheet. But the entire underlying reason for the material's existence has completely flipped.
It is a very grounding detail. It reminds everyone that underneath all these euro-denominated composite rates and centerline measurements and liability shifts, there are fragile human beings walking around a highly volatile, deeply unforgiving site.
We have journeyed all the way from the tiniest quarter-inch pipe fittings through the intricate rules of invisible vapor barriers and out to the massive cathedral-sized LNG storage tanks.
We really have. And the ultimate takeaway from dissecting these sources is recognizing what the FIDI Red Book schedules and preambles actually represent at their core.
What's that?
They are a staggering, obsessive attempt to turn the chaotic, three-dimensional, wildly unpredictable reality of a freezing cold industrial construction site into a flawless, perfectly predictable, two-dimensional financial matrix.
It is literally humanity's best attempt to tame the physical world with paperwork. By legally defining exactly how to measure the imaginary center line of a steel elbow, or exactly who pays the bill if a millimeter of paint is scratched off a bracket, or exactly how thick the closed-cell foam must be to stop a worker from losing a layer of skin to frostbite the contract, builds an artificial, perfectly ordered reality.
It creates a universe where cost certainty is actually possible before a single drop of concrete is even poured.
It replaces physical friction with administrative exactitude. But I want to leave you, the listener, with one final thought to ponder.
Oh, the blank space.
Yes. Despite this desperate, incredibly obsessive attempt to categorize every single millimeter of cold insulation, despite the thousands of rows of WBS codes and the brilliantly aggressive, all-inclusive rate preambles designed to eliminate every possible variable, the contract repeatedly includes a very curious, very quiet line item.
It appears subtly at the bottom of almost every sizing matrix in the schedule.
It is a single row that simply says, TBD contractor to identify other non-standard pipe sizes.
It is, in a way, a legal admission of defeat.
It really is a blank space in the perfect matrix. So I want you to ask yourself this. If a contract this obsessively detailed, backed by the best engineers, the smartest lawyers, and the most robust historical data in the world, still has to leave a blank space for the complete unknown, what does that say about our ability to ever truly predict the chaotic physical world?
No matter how perfect the preamble, there will always be a non-standard pipe waiting in the mud.
There will always be a variable we couldn't see coming. Thank you for taking this deep dive with us today. Next time you see a massive industrial structure or even just a heavy-duty insulated pipe running along the ceiling of a parking garage, we hope you look at it with a brand new appreciation.
Not just for the visible steel and the foam.
Right, but for the incredible invisible math, the deeply rigid rules, and the fascinating legal fictions that actually built it.
If you're interested in the templates, please visit our shop, the link is in the description.
Thanks for watching, please subscribe and see next time.